Today I want to talk about retries. Um, a few years ago, I was discussing with a couple of colleagues who were introducing a specification for creating, running, and operating dead letter queues in the context of a microservice environment. And the premise, so the problem that they were trying to solve was you imagine you have to, I don't know, process payment of a subscription, right? So you get from one service, a new user is created. From another service, you get, hey, the subscription was created, and now you have to process the payment. This means that you have this dependency on two different pieces of data in order to kick off your own jobs. So their idea was if one of those pieces of data is not there, no, so the reasoning was since the user is created first, you expect the user to be there. When the subscription information shows up, then you start processing. What happens if you get the subscription information, but the user is not there yet? Right? Which is a common problem in distributed environments. And the reasoning was idea was that if you get the second message and the first piece of data is not there, then you send the message to a dead letter queue, you get a human to look at it, you retry eventually, right? And this got me thinking about this concept of retrying. Um, and my conclusion was that uh, this is not a problem of availability. This is a problem of eventual consistency. And it was for me like an aha moment, right? Because it was very interesting to realize that if you design the system differently, the problem goes away. And why? Because we were solving the wrong problem, right? We were solving a problem we didn't have, which was the availability problem, right? What we were actually dealing with was an eventual consistency problem. So, what was my proposal in this case? Um, let's look at this as an eventual consistency problem. And as such, this means that this is not an error anymore, right? Downtime is an error. Eventual consistency is a property of the system. So you don't treat it as an exception, you treat it as something that you design your system for. In the same way that it's a different design of your system if you're communicating over HTTP or not, or it's a library that runs locally, it's going to be a different design of your system if you think of eventual consistency, right? And in this case, like there are, I guess, probably different approaches to this, different ways to solve this. What I was proposing is, I think, the most obvious one, which is the inbox pattern, in which you get one piece of data, you store it in your inbox, you get the second piece of data, you store it in the inbox, and only then you trigger the job, right? Um, and when I say piece of data, I don't mean user ID, I don't mean, it doesn't matter, right? You simply treat it as I got another piece of data. Do I have everything? No, okay, go to sleep. I got another piece of data, which you don't know if it's the first, the second, or the millionth one. You just know that you got another piece of data. You check the database, so I have everything I need to operate. Yes, trigger, go ahead, right? And I think that not only this problem of availability disappears, there is a lot of um, consequences, side effects that you don't have anymore, right? Or put it differently, as a side effect, you get a lot of other benefits. Like for example, if you have a dead letter queue and someone needs to come and look at the message and see, oh, yeah, there was downtime. Now we have a queue of who knows how many messages in this dead letter queue that need to be re-executed. What happens if order matters, right? What happens if you have downtime for 1 minute? You have three messages, and then the system comes back up. You continue operation, and now this the messages that come after will be processed before the ones that are in the letter queue, right? And this is far from a trigger problem to solve unless you design your system for eventual consistency. And now then this is not a problem anymore, right? As soon as you get the next message, you will process them in order. So what do I want to draw as a conclusion from this is that on the one hand, that I think it's fascinating how once you understand the problem that you're dealing with and you start seeing the problem for what it is and not, you're not solving the wrong problem, a whole set of issues disappear. Second, I think we should retry for transient errors, right? So, for example, there's a network error. Retry, because yes, we live in an environment spatially distributed that is very unpredictable. There are lots of moving parts. It's a miracle that things work honestly once you start thinking how many layers upon layers upon layers are of abstractions and moving parts. So, yes, things are going to fail, and sometimes you just need to retry once and that's it. Now, if it doesn't work the next time, what makes you think that it will work like 5 times? What is your guarantee? After you retry once, what is your guarantee that it will work twice, that it will work in 1 minute, that it will work in five? What I want you to take from this is how you sometimes, by thinking the problem in a different way, you eliminate the problem completely. What I want you to take is that if you're retrying more than once, I don't want to call it a cold smell because I don't think it's like I don't think the retries are considered harmful. But I do want you to think, to stop and think: is there another way where I can guarantee that the system will simply continue operating when something is down? Can I make it resilient so that it doesn't fail when the dependency is down? Is there a way that I can make it in a way self-healing, which I don't really understand what that term really means, but in this case, that the system will simply continue operating once the dependency is back up. So just stop and think and wonder: is this the right approach? Is there another way? Is this the correct way of thinking about this problem? Thank you for watching.